Alrighty, so this one will be on the 3-23 DeltaMath assignment with some basic exponent rules. First, I'm going to review some of the exponent rules with you. You don't really have to remember their exact names, but these are just some of the shortcuts used to help you simplify exponents. First of all, we have the product rule. Product is the answer to a multiplication problem. So if we're using the product rule, that means that two bases must be being multiplied by each other. So let's say I have like x to some power a times x to some power b, right? Any number could be there. If we have this, you can really just add the exponents together. And that would be the shortcut for simplifying something where you have the same base, x and x, and they have exponents. You can add the exponents together and keep the base the same, right? Have to have the same base. So then we also have a power rule, which is if we're raising an exponent to another power, raising a power to a power, that would look like if I had x to some power a raised to b, some power b, right? Some number there. You can multiply those together, okay? So this would be the same as x to the power of a times b. All right, again, we have the same base, and I know it's the same base x. I'm just going to use a different color here. If it's a base raised to a power, you keep the base the same and you're multiplying the exponents there. Then we also have the quotient rule, which is similar to the product rule, except a quotient means we're dividing something. So this would be like if we have x to some power a divided by x to some power b. Remember, a and b are just numbers. X can be any variable or number, right? This works as long as the x is the same. Really, this is the same as x to the a minus b power. You subtract them, okay? So instead of adding like with the quotient or with the product rule, you would be subtracting these. And again, the base has to be the same. You have to have the exact same base to be able to use this rule. Now we also have negative exponents sometimes. And with negative exponents, you always want to make them a positive exponent. So anytime you have a negative exponent, let's say you have x to some negative a power, to make that a positive, you would convert that into a fraction and you flip it to the denominator. And now it is a positive exponent. And that's just something you guys have to remember. I can totally go into depth explaining to you why this is the case. But for now, for this video purpose, let's just focus on the fact that that is what you do. Let's say you had a fraction and your negative exponent was on the bottom, the denominator. Well, you would flip that up to the numerator and now it'd be a positive exponent. Okay? So again, your base stays the same each time. All right? My base stayed the same x. And the exponent stays the same except for the fact that it switches to a positive. Same thing here. My base stayed the same. Now the last thing that you need to always remember is a zero exponent. If you have an exponent that is 0, that is always equal to 1. So x, any number, x raised to the 0 power equals 1 every single time. Okay, anything raised to the 0 power is 1. So, and I'm hoping, this goes without saying, but I'm hoping you've been writing this down. If you have not, please pause the video and write that down. Anything raised to the 0 power, power is 1. There, that was messy. Is equal to 1. Okay, and that's really, really important. All right, so we're going to use this as we move forward. So these are what we're going to be using. This is really, really important. So our first problem is simplify to a single power of 3, where we have 3 to the 8th power over 3 to the 3rd power. Now I'm going to show you the expanded version as well, okay? But first, using the quotient rule, because that's what this looks like here, we have division, and we have the same base 3 and 3, right? So we can take that base 3 and subtract the top exponent minus the bottom exponent, okay? So we'd get 3 to the 5th power. Make sure you pause the video to write this top part down because I won't always have the rules shown on the video. So you need to pause to write down the rules in order to access them during the video. Okay, so the reason why this works is because if you were to expand out 3 to the 8th over 3 to the 3rd, 3 to the 8th is 3 times 3. It's by itself 8 times. 6, 7, 8. 3 to the 3rd power is multiplying by itself 3 times. Now you can simplify, okay? 3 over 3 is just 1, right? Or you can just cross them out like this as 1s. And now all we have left on the numerator is 3 times itself 5 times. So that is equal to 3 to the 5th power, which is exactly what we got here as well. So yeah, sure, you could expand things out, but once the numbers get way bigger, that's going to be way more time consuming than using the properties of exponents, like 8 minus 3. So this one's going to be to the 5th power. And remember, their explanations are so good in DeltaMath. Please make sure you're reviewing them or using their solution examples as well. So good. They showed you both methods. So method 1, expand, which would be this method over here that I did, the expanding method. Method 2, subtract the exponents. Okay. All right, see another one. This one's the same as before, so I'm going to skip that one. Okay, so this one's a new one. It's a power rule. So if we had 3 to the 6th power raised to the 2nd power, using the power rule, you would just multiply the exponents. This would be 3 to the 6 times 2 power, which is 3 to the 12th power. You can also expand it. So 3 to the 6th squared is the same as 3 to the 6th times 3 to the 6th. Now here you might recognize that you can add these two exponents because we're multiplying the same base, but I want to show you completely expanded out what happens. So this is 3 times itself 6 times. And same as this one, so I'm just going to copy this. Okay, 3 times itself 6 times. So then if you add up how many total 3's there are, we have 12 3's being multiplied. That's the same as 3 to the 12th power. Okay, so that's why whenever we have a power raised to a power like this, power raised to a power, you can just multiply because you're duplicating it that many times, right? You're duplicating that exponent that many times here and here. That's what that means. So instead of expanding it all the way out like this, you can just multiply the exponents. 12. Sorry, I have the sniffles today. So again, they show you the expansion, and if you just use the power rule, which is multiplying the exponents together. Okay. Again, I'm referring back to the product rule, power rule, quotient rule, negative exponent rule, all that good stuff there. All right, this one's a good one. Okay. So we have an invisible 1 here somewhere. So we have 4 squared, and I don't like using the x as the times since we deal with exponents now, or variables. Sorry, variables. I'm going to use the dot. 4 squared times 4. Okay. Now, some of you might not know what to do here, but you have to realize that we do have a negative, or an invisible 1 exponent here. This is really 4 to the 1st power. Okay. So if we were to use the product rule, because two things are being multiplied here, it's going to be 4 to the power of 2 plus 1. This is really 4 cubed. This is because if you were to use the expansion rule, just like this, 4 squared is really 4 times 4. And then times this 4 that was here, that's 4 to the 3rd power, right? So adding the exponents is the exact same thing as expanding it. And again, here they show you the expansion. And I love their explanation, okay? Everything is there for you. See if I can't find any zero exponents. There might not be any in this one. Oh well, I'll just go ahead and do a couple more here. So 4 to the third over 4 squared is the same as 4 to the 3 minus 2, which is 4 to the first, or just 4. Okay, but in this case, they'll want you guys to write down 4 to the first. Again, if I were to instead expand it, it's going to look like this here. And then you can cancel out things that divide out to 1. We just get 4. And anything that's just a number is always raised to the first power. So if you needed to put in an exponent, like for this problem in DeltaMath, that's what you would do. Okay. Again, you guys have access to a bunch of these example solutions as well. So make sure you're using those. Okay, they're very helpful. So here we have 3 to the third to the fourth power. So again, you can just multiply the exponents. You get 3 to the 12th power. Okay, so this would be the same as 3 times 3 times 3 times itself 4 times, raised to the fourth power. Oops. Duplicate that again. Right? And then if you add up all those 3's, again, you get 3 to the 12th power. So you can do it either way. Okay. So with this, you have to begin to identify which rule will be helpful for you, which rule you can or cannot use. Okay. Really, for power rule, look for the parentheses. Anything that has like a power right next to a power with parentheses in between them, that's power rule, right? You're raising a power to a power. Two things that are being multiplied side by side, product rule. You can add the exponents. Of course, division, quotient rule. Subtract the exponents. And then the negative exponents we'll get to practicing here soon. All right, so the next one, exponent rules, variables only. I think it's the same thing, just with only variables. So this one before was numbers, now we have variables. So if I have n squared to the fifth power, that is my power rule. I have a power raised to another power. So I'm going to be multiplying those two numbers and get n to the 10th power. If you want to see it expanded, n squared to the fifth power would be equal to n squared times itself 5 times. Okay, n squared is really just n times n. So if I were to rewrite all of these, and this is just completely expanding everything out, and then add all of these n's together, I have 10 n's being multiplied by each other, which means I could rewrite as n to the 10th power. So here with this guy here, you're going to have to type in the letter n. And then you use this a to the b here to pop it up to the exponent if you're using their little keyboard, into the 10th. On your keyboard, you can also use Shift 6. So you click Shift and then you click 6 because that'll do the little caret. And that'll pop up so you can type in whatever exponent you want. So this is on your actual keyboard. Okay. Again, they show you both methods there. And make sure you guys are actually reading like what they're saying here. Multiply n squared times itself 5 times. Those things are the things I'm actually saying in the video. All right, this is another product rule. R cubed raised to the 5th power. We multiply the powers. We get r to the 15th power. Okay. Feel free to pause if you need to see the expanded version here. If I can find a different one. Here we go. X to the 6 times x. So again, you could just expand it all, right? But that's going to take a lot longer. X, recognize that it does have an exponent. We just don't see it because we don't have to write it if it's a 1, right? So this one here, sorry, I should have used like this. It's not 0. I was trying to draw an empty circle. But that has an exponent of 1, okay? So we can add those two exponents together and get x to the 7th power. And once I type it in here, if you need to see the expanded version, you can see it if you pause the video on their explanation there. You can pause the video to see it. It's important for you to understand why these rules work. It's another similar one. If there's any division here. What? No, I don't want to check. No. Weird. Okay, well, there is going to be more division in a future problem, so I'm going to go ahead and move beyond this. I'll do this one real quick. C to the 5th times C to the 3rd. Okay, this one is not power rule. You see how like this one also had 3 and 5, that's why I grabbed this one. This one is product rule, because these two things are being multiplied, the bases, and we can add their exponents together. Because if you were to expand it, that's how many you would have, 8 C's being multiplied together. So if you were to use the expansion method, and you guys can always think, what would this look like if I expanded it, right? And that can always help you with seeing whether or not you should be multiplying your exponents or adding your exponents together. Okay, pause the video if you need that explanation. And I'm going to move on to the next assignment. Oops. All right, which expression is equivalent to 5 to the negative 1 squared? So, first thing we ought to do is make sure you guys know how to simplify 5 to the negative 1 squared. There's a couple ways you can tackle this problem. First, you can use the power rule. So that means we're going to multiply negative 1 times 2, which we get 5 to the negative 2 power. Now remember, we always have to have positive exponents. So to make this a positive, we have to flip this to the denominator, just like that, and now it's a positive 5 squared, and the 2 is now positive. 5 squared is 25. So this one would be equal to the first one, 1 over 25. Okay. Another way, if you had first decided to tackle that negative exponent there, that would be the same as inside these parentheses, 1 over 5 to the positive first power squared, which is just 1 over 5 squared, right? Now, with this squared here, you would distribute to each part inside the parentheses. So this is going to give us 1 squared over 5 squared. 1 squared is 1, because 1 times 1 is 1. 5 squared is 25. 25, because it's 5 times 5. Okay? You could have also, instead of distributing the 2, 1/5 squared is the same as 1/5 times 1/5, which is 1 over 25. If you just multiply them straight across. Let's see which way they decided to do it. They might show you. Oh, yeah. So they did the first way I did up here. Okay? Which would be my preferred way as well, honestly. All right, let's see some more. Okay, so again, you guys need to first know how to simplify these before you even look at the answer choices, right? Don't even look at them yet. Just work through to see if you can simplify this first. So, there's again multiple ways you can do this problem. If you immediately see that you can use quotient rule, then you can set it up. It'd be 4 cubed minus negative 3, okay? So I'm subtracting this here. So it's always top minus the bottom. So the top exponent 3 minus negative 3. Now you guys should see here that 3 minus negative 3 is really the same thing as 3 plus 3, because these two negatives make a positive. So this is going to be 4 to the positive 6th power. Now let's say if instead you wanted to take care of that negative exponent first, that would be a good plan, okay? What you would do is you would take this and flip it up to the top to take care of that negative exponent and make it a positive. So now that bottom part comes up here. Now it's times 4 to the positive 3 power. And now you see that we have 4 to the 3 plus 3 power, which is 4 to the 6th power. Because again, if you guys were to expand these out like this, you see we have 6 4s being multiplied together, which is equal to 4 to the 6th power. Could be that one. This one has a lot of negatives in it. All right, so again, there's going to be two different ways to show this one, to solve it. So I'll use just the quotient rule first. You just have to be careful with subtracting your negatives. So definitely use a calculator if you're not confident or if you sometimes make mistakes with number lines. Take your time and or use a calculator. All right, so this one is the base is 4, right? They both share the common base of 4. So we can subtract the top exponent minus the bottom exponent. I'm just going to use my highlighters for now. Minus the bottom exponent. So the top one is negative 8 minus the bottom is negative 4. I always like to put that in parentheses if I have two negatives side by side. Again, these two negatives make a positive when subtracting. So this is really 4 to the negative 8 plus 4, which is going to be 4 to the negative 4 power. Now, I don't see that as an answer choice, and it's because they made it a positive. So we would have to rewrite this as 1 over 4 to the positive 4 power. Okay? So this would be your final answer. Now, another thing you guys could do is a double flip, basically. So if you're like, okay, well, I have this negative exponent here. This one also has a negative exponent. You flip this one to the bottom, and you flip this one to the top to make them both positive now. So that means the 4 to the negative 4 would go up to the top to become positive 4 in the exponent there, 4 to the positive 4, and then the 4 to the negative 8 comes down to the bottom to become a positive 4 to the 8th power. And then here you can do a variety of things. You can do your quotient rule. 4 to the 4 minus 8 would be 4 to the negative 4 equals 1 over 4 to the 4th. You can also imagine if you were to expand these out. This would be 4 times itself 4 times. This would be 4 times itself 8 times. And if you were to cancel out all the 4s that lined up, because 4 over 4 is 1, 1, 1, 1. And then technically you can always have times 1, and that's why we get this 1 up top by itself. You have to have something there, right? On the bottom we have 4 to the 4th power, because there's 4 4s being multiplied here. And on the top we just have a 1 left. So this would be 1 over 4 to the 4th power. Exponents are my favorite. There you go. So they did what I did first. They did this first method here. Again, you can use any kind of method, right? It just depends on how your brain recognizes it first. As long as you get to the right answer. I don't mind what method you use. Okay, this one's a little bit easier. Really, I think the hardest ones are the quotient ones where you have to subtract negatives and whatnot, right? Those are kind of a pain. So this one is 3 to the 4th in parentheses raised to the negative 4th power. This one you can multiply. It is quotient rule, or I'm sorry, power rule. My brain is struggling doing these videos. I haven't made them in a while. All right, so this would be 3 to the 4 times negative 4. 3 to the negative 16. And technically, I mean, we would want to go forward and make this 1 over 3 to the 16th, so then we have a positive exponent, but it's just asking for which expression is equivalent to 3 to the 4th raised to the negative 4th power. It would be 3 to the negative 16th. And even like they might have even written this as an option, right? Probably not because they want you to go further, but I mean, that would also be an equivalent expression to that original one that they gave us. Okay. So this one, again, there's multiple ways to do it. Okay. Oh, I guess I should have shown you another way to do this one here, but I think this is the easiest way. So I'll leave it at that for that one. All right, so this one here, 2 to the negative 2 times 2 to the negative 2. I don't get it. My nose hasn't ran all day, and now that I'm doing a video, I really, really need to blow my nose, but I cannot do it to you guys in the video. This is killing me. All right, so what you would do here is product rule. This would be 2 to the negative 2 plus negative 2. Okay? This would end up being 2 to the negative 4th power, or 1 over 2 to the 4th power. All right? Another way that you could simplify this is if you realize that these each are equal to 1 over 2 to the positive 2 power. Right? So then this would be 1 over, if you multiply straight across, 2 squared times 2 squared, 1 over 2 to the 2 plus 2, 1 over 2 to the 4th. But you see here that they actually left it in negative exponent form. But even if you did it this way, you should recognize that 1 over 2 to the 4th is equal to 2 to the negative 4th power. Because you can just flip exponents up and down and change their signs of the exponent. So again, this then would just be 1 to the, and then if I flipped it back up, it'd be 2 to the negative 4th, right? So those are all equivalent. But doing this first one here, that's probably the best way, is just using the product rule. Just be really careful with adding your exponents if there's negatives involved. Okay, just be really careful with that. So if you're using this video to help you through the assignment, I think I'm going to stop there for this part of it and move on to the exponential rules. You guys need to keep going through these problems, right? You can look at the solutions, make sure you understand what they're doing. Always try the problem first on your own, but there are so many great examples here. You can go above and beyond what I assigned. I said 5 problems, get at least 5 problems right, you know, with all the penalties as well in case you're getting those. But you guys can always show examples first, take notes on it, try the problem on your own, etc. Okay? So let's see these exponential rules. This is what I think a lot of people need help on the most. All right, so express the following fraction in simplest form using only positive exponents. So that means if we come across any negative exponents, we're going to have to flip it, okay? All right, so let me write this out. So we have 4. Remember, if you guys are watching this video, you need to be writing down these problems with me, right? Pause the video, see if you can try it on your own, etc. Take notes. That's how you learn from videos, is really being an active learner. All right, so first things first, just like with PEMDAS, I want to tackle what's going on around here. There's nothing I can simplify inside, but there's an exponent there, okay? So this exponent, these two are going to be multiplied together. So that's the power rule. So this would be 4 times k to the 8th power for the top. And I'm just not going to write it out completely every time, but this is what I'm doing. I'm using the power rule to multiply the exponents. If it's a power raised to a power, I need to multiply those together. And then this is over 20k. Now I need to see if I can simplify my numbers at all. I'm so sorry, guys. My allergies are killing me. Um, if I can simplify my numbers at all. Okay, so I have, by numbers, I mean 4 over 20. All right, so you guys have to know how to simplify fractions. I know that 4 and 20 are both divisible by 2, and they're also both divisible by, by 4. Okay, so that's going to equal 4 divided by 4 is 1, 20 divided by 4 is 5. So that helps me take care of that. And then if we focus just on this part here, k to the 8th over k. That is the same as k to the 8th minus 1, okay? Because really the bottom one has an exponent of 1 there. So if we were to subtract those two numbers, 8 minus 1 is 7. And it's going to be a positive, so you guys see how the bigger number is up top here. The 1 is down here. So that will go up top here, k to the 7th power. Now, if you look here, I don't have anything more to simplify. The 1 times, let me erase this here. The 1 times k to the 7th is really just k to the 7th, and then the 5 is still on the bottom. So this would be my most simplified answer here. And then, so here you're going to have to like space out of it. Let me see if it lets me. I have to use my arrows here. And then divide by 5. Okay. So for these, you guys definitely want to read their step-by-steps. I think the steps already automatically pop up for you, but since I'm on my iPad on a smaller screen, I have to actually click to see the steps. So if we go on here, oops, if we go to the next one, oh, there's a new one there. All right, so let's see here. Okay, so again, you want to focus on the parentheses, all right? You want to ask yourself, okay, do I need to distribute any exponents? Yes, just like sometimes we have to distribute a coefficient, like if there's a number out here, we need to worry about distributing those exponents as well. So here I have this 2 needs to be distributed to the base 2 and to this exponent here. Technically, this 2 has a raised power of 1, right? But we don't have to worry about that here. We can just put the exponent 2 with the base 2. So this is going to be equal to 2 to the 2nd power, then times p. I don't have to put the dot, you can if you want, but it would be times p to the 3rd times that 2 that we distributed, okay? And then the bottom we can just leave for now as 10p cubed. All right, so 2 squared is 4. P to the 3 times 2 is going to be p to the 6th power. And it's over 10 to the p cubed. So now that we have simplified what was going on here with the exponent raised to an exponent, and we distributed that exponent in, now we have this here. And let me just duplicate this and take this down here so I have some more room. Now you want to look at the numbers and ask yourself, okay, is 4/10 a fraction we can simplify? It definitely is. All right, so if we just focus on 4/10, they're both divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Excuse me, that was a sneeze. Sorry. Okay, so you guys could have also shown that by just dividing top and bottom by 2 here. Okay, we get 2/5. All right, so this is just me kind of showing you off to the side here. And then now we also have p to the 6th over p cubed. So you can rewrite that if you wanted to. You can write it off to the side here. P to the 6th over P cubed. This is quotient rule. So it's going to be P to the 6th minus 3. It's going to be P to the positive 3 power. So that's going to go up in the numerator. Okay, just like that. So this would be our simplest expression, right? We cannot simplify 2/5 anymore. It wants it to be in fraction form, so we leave it as 2/5, not as a decimal, and the P cubed would go on top with the numerator. Just like that. And then again, you can kind of see that they like explain out what they did, and then you have to make sure that you're really reading their steps. Okay? I'm doing my best to like write everything off to the side for you so you can see what I'm doing within each step. So that's why I have all these arrows and whatnot. All right, let's see another one. So this one I have 2 times j cubed, 10j to the 7th. Now here you see that the 3 up in the top is only attached to the set of parentheses. So this 2 over here is not going to get that exponent of 3, just the j. So this is equal to 2j cubed over 10j to the 7th. Okay. Now here we want to see, okay, can we simplify the fraction 2 over 10? We can. We can divide top and bottom by 2. And that is going to give us 2 divided by 2 on top is 1. 10 divided by 2 on the bottom is 5, because 2/10 equals 1/5, right? And then now with the j's here, actually I'm going to use a highlighter instead. J cubed over j to the 7th. You can kind of tell where the j is going to end up being. It's going to end up being on the denominator because j to the 7th is bigger than j to the 3rd. So it's going to end up being we're going to have more j's left over on the bottom. So if I were to write this off to the side, it'd be j to the 3rd over j to the 7th. If you subtract the top minus the bottom, we're going to get j to the negative 4th, which if with positive exponents, we would flip it. It'd be 1 over j to the positive 4th power, just like that. Now, you guys might have seen that if like the bigger one is down in the bottom, I don't know if DeltaMath did this or Khan Academy, somewhere did it, where they would say, okay, then this is equal to 1 over j to the 7 minus 3. So if the bigger one was in the bottom, the bigger exponent, then you would put the subtraction piece in the bottom. And that's totally fine. I mean, because look, we get 1 over j to the 4th each time, right? So that would mean that we would do like times 1 times j to the 4th here. So I'm just basically moving this fraction up into my original fraction. And then that's just 1 times 1 is just 1. 5 times j to the 4th is 5j to the 4th. So that would be our final answer. So these two are not our final answers. Those were just the simplified of the j's. And then 1 over 5j to the 4th would be our final answer. Oops. Okay. Again, you need to read what they're doing in each of the steps in order to really understand. I wish they showed a little bit more work, but I'm sure it would be a lot of work to show with like the computer program. Okay. All right. So I'm hoping that that helps. I'll do one more of this one because I know this one I think was giving people the most trouble. But I mean, really, it just takes practice and you have to realize what you're simplifying together, right? So the 2 and the 10 up here went together and the j's went together. So you had to kind of look at those as separate things and then put them together in the end once you have them all simplified. So that's really important to recognize. All right, so this one here we have 3 times c to the 5th raised to the 4th power over 4c squared. Now, this exponent here, okay, there, the fourth is only raising that set of parentheses to the fourth power. So the 3 does not get that exponent. So the 3 is just all by itself out here. But the c to the fifth needs to be multiplied by 4. The exponent does. Okay? That 5 times 4 needs to be multiplied together. So you can even write it right here. 5 times 4, and then here it would just be 20. Okay? And then the bottom we have 4c squared. Now, if we're looking at our numbers here, 3/4, can we simplify that fraction down anymore? Nope, it's already in simplest form. So we're going to leave it as is. But here, the c to the 20th over c squared, we can definitely simplify that. So c to the 20th over c squared is equal to c to the 20th minus 2, which is c to the 18th power. And that's going to go on the top. Okay, so this is going to be 3c to the 18th power over 4. And that would be your final answer for this one. Just over 4. Okay. All right, so the last two, scientific notation. Okay. The handout 4 video is really good showing you guys scientific notation. So make sure that you have watched the videos for handout 4. I'm only going to do a couple of these because I do feel like that video is really good and I don't want to make this video that I'm making too much longer for you guys. So if you're multiplying times 10 squared, of course your guys' calculator can do this, but you guys need to understand how to do it yourself. So I have 9.1. And then this times 10 to the positive 2 power means I'm moving my place value decimal 2 to the right. And so that means I need to add in a 0 in this empty place here. And now this is 910, right? And if you guys were to use your calculator to do that, you would definitely get 910. Okay? So then 4 times 10 to the third power. You guys will see in scientific notation is the only time I use an x for times, just because that's the most common symbol that is used for scientific notation. So 4, anytime you have a whole number, it'd be like 4.0, right? 4.0 is how you can imagine it. So that's where the decimal place value is right after the 4. And this 3 is telling me to move the decimal 3 times to the right because it's a positive 3. So 3 jumps to the right. So now it's not here anymore, okay? It's over at the end, so my number is now 4,000. This is just a way to learn to write really big or really, really small numbers. All right, so 2.2 times 10 to the fourth. So again, you just take your number, and the fourth power is telling me to move it 4 times to the right. And anywhere where you have a jump that doesn't have a number, you need to put a 0 in there. So my new number is 22 with 3 zeros, which means every 3 zeros, right, or every, like, from the end, that's a comma, okay? So this is going to be 22,000, which in DeltaMath, you guys don't have to put the commas. I don't think it wants you to, actually. 22,000. Suppose I don't see any negatives here. There we go. Okay. So 4.4, I'll leave that there just in case. So here we have 4.4 times 10 to the negative fourth power. So again, you still want to write out your number, but the negative fourth power is telling me to go to the left, to move your decimal to the left 4 places. So I'm going to go 1, 2, 3, 4. And every single jump, I'm going to add in a 0. Okay, So this would be equal, and I always put a 0 out in front too, but this would be equal to 0.00044. And I always like to add a 0 out in front just so that you don't miss that decimal. So this would be 0.00044. Okay? So if it's a negative exponent, you move the decimal place to the left. If it's a positive exponent, you're moving it to the right. And this is only with scientific notation, okay? Nothing to do with the simplifying exponents from previous. This is just some number times 10 raised to some power. 10 has the ability to move decimal places if you're multiplying by 10, by powers of 10. All right, here's one more with the negative exponent that I'll do. So we have 1.3 times 10 to the negative 6 power. So I'm going to write out the number, and then I'm just going to focus on moving the decimal 6 places to the left. 1, 2, 3, 4, 5, 6. Sorry, I kind of ran out of room here. So that means I need to add in 5 zeros. So this is going to be 0.000013. And then again, I always like to add a 0 out in front of the decimal just so it's more clear what the number is. So 0.0005013. There we go. Be really careful with counting your zeros. All right, last one. We're going to be given a number and we have to write it in scientific notation. So if you notice something, all of these numbers up here, 1.3, 4.4, 2.2, 4 or 4.04, 9.1. They are all numbers between 1 and 10. So in scientific notation, your first number has to be a number between 1 and 10. Okay? So I'll go ahead and write their little setup here. I'll write 1 through 10 times 10 to some power, right? So this is the setup for scientific notation. So if we have 0.016, what I always do is I just focus on the numbers themselves. We have 1, 6, or any number besides 0, 1, 6. And then I ask myself, where do I need to put a decimal to make 1, 6 a number between 1 and 10? I can't put it in front of the 6, or in front of the 1, because it would be 0.16, and that's smaller than 1. I can't put it at the end because then that would be 16, and then it would be too big. It'd be bigger than 10. So it's going to have to go right in between the 1 and the 6. Okay? So this one's going to have to be 1.6. And then you ask yourself, okay, well then how would I go back to that original decimal where the actual number is, right? Where the actual decimal is, which is right here. You would have to go to the left 2 times. So that would be 10 to the negative 2 power. Should make this a little bit bigger. 10 to the negative 2 power. Okay, so let's see if that works. So if I did 1.6, whoops, 10 to the negative 2 power. Yep. So 0.016 is a small number, so it should be written as a, where a is some number between 1 and 10, times 10 to some negative exponent, right? I don't like how they say to the right here. I guess from what they're talking about is like here I technically moved, 2 decimal places to the right, so then to go backwards it would be a negative. But really all you guys got to do is think, okay, if I was given 1.6 and I needed to get, so if I was given 1.6 and I needed that to become 0.016, what would I do with this decimal? Well, I'd move it to the left 2 times, right? And then I'd get 0.016. So that's what you guys need to think about when doing scientific notation. Okay, I'm going to use the same setup here. All right, so let's see a new one. Write the number 590. So 590 in scientific notation. So again, I'm going to focus on the numbers that are not 0. and ask myself, okay, where do I need to put a decimal there to make that a number between 1 and 10? The only place that would work is if I put it right here between the 5 and the 9. So then my number would be 5.9. Now technically the original decimal, right, is here at the end. So to get to that decimal, by multiplying by a power of 10, I would be going to the right 2 times. So this is going to be a positive 2. And again, you guys can always type in 5 times 9 times 10 to the positive 2 value in your calculator and make sure that you get 590, right? This should equal 590. So that's really important to also know to check your work. This is going to be 5.9 times 10 to the positive 2 power. All right. So just be careful with reading DeltaMath like to the left, to the right, etc. Really just write it out like I did here. Watch the handout 4 video for the unit on exponents and scientific notation. It does a really good job with practicing scientific notation, and that's all you need to know for the test. Okay, so best of luck. Finish up this assignment. Make sure that you're really good with that exponential rules one. All right, this one I will tell you is very important to know. All right, very important. You got this.